Hello, grade 9s. This is point linear system algebraically. We saw the intersection point. So I'm going to start off with this. I want you to graph and find the solution to this 2x plus 3 and y equals 3x minus 7. So with my first equation, I start with up, which is positive 3 is negative 2. So down 2, right 1, and connect. There's my red line. Line y equals 3x minus 7. That's my y-intercept. My right one and connect. And there we are trying to find the intersection. My lines, I didn't use a ruler, wasn't so great. So trying to, but I'm not 100% sure. So that's the problem with solving perfectly straight, or quite possibly the intersection, they aren't integer values. It's not 2, negative 1, it could be 2. So that's not something I'd be able to. So how do I resolve this problem? Well, what I do algebraically, and that way I will always get. So let's look at an analogy here. If I told you that I have a dog named Max, if it was a poodle, I'd be able to conclude that Max and say y equals negative 2x plus 3. 3 I conclude then that negative 2x plus 3x minus 7 because they are both y, right? They're both y. When I do with an equation with one variable, right? Bring the x's to one side, numbers to the other, and I'd be able to solve for x. How to go about solving algebraically? Our first method is called substitution. When I have one variable, so we're going to do the exact same problem that we just graphed, okay? So my first equation was y equals negative 2x. My second is y equals 3x minus 7. First thing, I make things very clear in my instructions. I've got equation 1. In equation 1, I have 2x plus 3. I'm going to take this entire, substitute it in for y in equation 2. So here are my substitute equation 1 into equation 2, that y. So I end up with negative 2x plus 3, all my to the other. So I end up with negative 5x, 10, divide both sides by negative x equals negative 2. So I'm going to take the solution x equals positive 2, and which one you pick. I'm going to sub it into equation 1, negative 2 times 2 plus 3, solve y equals negative 1. So get that same answer, y equals negative 1. So in fact, my graphing was pretty good. Okay, so two equations. One, x equals 2y plus 3. I'm going to mark that as equation. I've got an x and a y. In my second equation, so that's what I'm going to substitute in. I'm going to take y plus 3, and I'm going to sub it into equation 1. Equation 1, so I have 3 times all of this 3 equals 21. I continue to solve. I distribute my 3 equals 21. All my constants to the other, 12 both sides by 12. Take this y equals 1, and I'm going to sub it into either equation 1. Easier to sub into equation 2 because here. But either way, we will get the same answer. So x equals 5. Therefore, xy, right, that's my POI, equals 5, 1. Make sure you give that therefore statement telling me what that was a method called substitution. We also have a method which is called elimination. When I have two equations where I have the same coefficient in front of one of the variables. So for example, here I've got equation 1 is 4x plus 2y equals 6. Equation 2, 6x. So notice that the x coefficients are 4 and 6. They're different. My y coefficients, I've got a positive. This is perfect for elimination. When I have one, I'm going to add my two equations. When I add, I move x plus 6x, which is 10x, minus 2y, so that's 0, it's eliminated, right? Positive 2y and negative 2y, they cancel out. And then 6 plus 14x equals 20, divide both. And from here I proceed, your choice, 1 or 2, for y, and we end up with y equals negative. Point of intersection here has coordinates 2, negative 1. Let's try this one more time. 3x minus 6y. So looking at my coefficients, my x coefficients are 3, coefficients are negative 6 and negative 4. So I'm going to go back to my x. They're the same. They're both 3. Now, in the added, if I were to add 3x and 3x, but if I subtract my equation, x minus 3x, and that gives me quickly again, only this time we are subtracting when we move down. So we want to be really careful. Negative 6y or y, that becomes negative 6y plus 4y. That gives me negative 2y. negative 18, that's negative 18 plus 8, which gives me negative 10. So when I subtract my equations, I'm left with negative 10, divide both sides by negative 2, and I'm left with 5. I take that y equals positive 5, and I'm going to substitute it into either equation 1. So I'm going to sub it into 1. 3x minus 6 times 5 equals negative 8, negative to the right-hand side. Divide both sides by coordinates 4, 5. So I'm going to scroll back up for one thing. Some students really don't like subtracting signs. So an easy fix when I to take your either first or second equation, so in this case I'll take my second equation, and multiply everything by negative 1. Remember, an equation by the same number, I'm not changing anything. I'm changing if I were to graph it. So when I multiply everything by negative 1, I end up with negative 3x plus 4y. Now, if you prefer, you can add 3x, that's 0, negative 6y, positive 4y, that's negative 2y, negative 18 plus 8 is the same solution as the blue. So you get to choose what you prefer. Add, simply go ahead and negative 1, and that way you'll always be able to. Okay, so for homework, this is a solution. So I've set up 10 problems for you here. I'm going to 5 using substitution, because you'll notice there's always an isolated y, y. There's always something isolated. So negative 2y, positive y, negative y, 4x, 4x, 5x, 5x. Okay, so go ahead and try those problems out algebraically. And then in your textbook, there are a couple of word problems I'd like you to look at. Homework 1 and 2 that is not in your textbook. Solutions are here for you. Have a good day, guys. Let me know if you have